Good morning, good afternoon, wherever you're watching this from in the world. Massive thanks to AnimX for having me on. First things first, introductions. So, hello, my name is Matthew Lake. I'm the technical animator at Lucid Games in Liverpool. I've been working here since I graduated from Teesside University with a degree in animation back in 2017. Lucid is my first professional games industry job, and prior to Lucid, aside from studying, I worked on a fan Halo game called Installation 01 in the Unity game engine. I did a 4-minute cinematic as part of my final university project, which some of you may have seen. Fortunately, this trailer landed me my job at Lucid, which has been an incredible opportunity and amazing experience to bring to life. Destruction AllStars. If you haven't heard of us, we are a PlayStation 5 exclusive title. We are currently live, so if you go get yourself PlayStation Plus, you can grab this game for free for the next few days. I do believe it ends at the end of March. So I'm just going to play a quick trailer to get you all acquainted with the game and show you a little bit about what we're about. So as you can see, we are a hybrid character and vehicle combat game. There's lots of interesting interplay between the two modes of transport. It didn't always look that way. Let's take a step back in time to August of 2017 where we started. This is a super early prototype built in Unreal. This was taken shortly after the animation director and myself joined the studio. Going in, we knew we had some goals for characters that Lucid had never really dabbled in before, so all of our character tech was effectively starting from scratch on a new engine for a new console. While we didn't have the tools, we did have the wealth of knowledge and principles, and I was fortunate enough to be surrounded by some incredibly talented people, some of which have been in the games industry more years than I've been alive. Mike Waterworth. And to add to that, I had no professional experience myself, but in some cases I did have more Unreal Engine experience than some staff around me, so it was a nice marriage of these two backgrounds. So what is a technical animator? Different studios may refer to this title under different names, such as Character TD or Character Technical Artist, essentially a combination of an animator, a rigger, and a tech artist. They specialise in character work but aren't limited to it, and we are essentially the animator's bridge to all of the disciplines and the game. Responsibilities range from rigging, state machines, tools and control rigs, shaders and maintenance, pipeline development and R&D, and even animation on occasion. Everything character or character-related support. I was originally hired as a gameplay animator at Lucid, but quickly moved into a technical animation role within the first few months as there was a gap in our team. The job role is a perpetual cycle of problem solving, but is also a super diverse job role touching a wide range of tasks from skeletons to cutscenes, trailers, and even odd things like producing cardboard cutouts for use at the PlayStation Fiesta Bowl audience. The variety in the work keeps things fresh and it is very rewarding. So early on, Christian Jonjuk, our animation director, sat down with me and set out several mandates for characters as a whole. Rather than specifics, it was more the mind mentality that should be considered when deciding upon a system or choice. Future-proof systems. So we're making a new IP, we knew we needed to be adaptable. Early on, we've got the high-level view of the game of cars can smash cars and you can run around on foot. But when you're still finding the game, you don't really know what does and doesn't work. So you need to create everything with the ability to be tweaked at any point or removed entirely without breaking anything. Shareable systems. To bring 16 characters to life, we knew that was a mammoth task for our small team, so we knew we needed to work smart, and rather than brute force quantity of content, we needed to share as much as possible where possible. We want to remove as much friction from our tools and pipelines as possible to let animators animate and see their work in engine, which will hopefully get those creative juices flowing. Varying degrees of experience from junior to senior will be using our pipeline, so we want to be as accessible as possible. They don't want to jump through 8 hoops, 20 sub-menus, or read documentation to complete that task. Things should be intuitive. Fundamentally, with our small team, we knew we wanted to be efficient, cheap, and smart. For our engine, we use a modified in-house version of Unreal 4. We shipped with 4.25, but we did start with 4.16. We kept incrementing our version in parallel to the vanilla Unreal to ensure we had the latest SDKs that was required to ship on PS5. For the character creation process, we were mostly DCC agnostic. We allowed you to utilize whatever software you felt most comfortable in. Animation supported Maya, Motion Builder, and Max, with the primary rigging done in Maya and then rebuilt in Motion Builder or Max when and if necessary. So, let me introduce you to our character roster. So as you can see, we've got 16 characters of all varied shapes and sizes. Technically, we do have 18 characters as there's 2 non-playable AI characters in the game. So, I'm going to explain some of the processes of how we brought them to life. So, fundamentals, naming conventions, or more specifically in this case, character IDs. As I'm sure everyone can imagine with a working title, characters' final names change a lot, some several times. So one thing we implemented was a standardized production ID associated with characters that would never change throughout development. The codenames were initially based on their very early names, so the character like WF is Wolf or PK is Pink. These were typically throwaway names, but based on an early piece of concept art for them. Like Fuego has the words Hellbound as a brand printed on his shirt, and that's still there to this day. We enforced this standardization every level of their asset. So skeletal meshes had their ID, textures had their ID, animations have their ID. You want to find something for that character, you can just search their ID. It's all lovely and standardized. We didn't want to have files referencing every version of every character's name, such as a texture called Wolf and a texture called Lupita, and then having to decipher if they're both for the same character or not. It can get quite confusing. Or even a worse situation where we have to go back over and rename files every time a character got a new name. This helped a lot, and we even had an extra ID of XX in animation, which meant generic or no personality. Asset auditing is also super important. It helps identify human errors fast and get them fixed as quickly as possible. For character art, we have a model auditing tool that helps identify objective issues of asset. So it scans through and creates a report that helps an artist identify issues such as engons, laminar faces, history, stray verts, etc. The tool can simply be ran and a list of errors is populated. The artist can then click the error in the list and click select. It can then take them directly to the error so they can fix it quickly. If there's issues with the UV, it'll open the UV editor and show them where exactly the issue is. If there's an engon, it'll select it and frame the engon so the user can find it easy. This art tool is embedded into every artist Maya, allowing them to fix problems before they get passed down the chain. It prevents the situation where a bad model is sent to me and only halfway through rigging it do I realise that there's issues with it and it needs to be sent back, so we are saving time by auditing early. For rigging, we also have a similar thing for skeleton audits that check for issues for the rigs prior to exporting, and it basically won't allow you to export until it's clean, which prevents dirt accumulating in the engine. On the engine side, we also have tools that check for naming convention mismatches when creating a file, and it'll flag it if it's incorrect. In addition, we have automated audits that run nightly that check for various issues of the assets in the engine. Everything from redirected checks if animations have illegal curves or incorrect retarget settings, or if LODs even have bones removed in them. Pretty much any check we want, we can ensure it's proper. As an added bonus, if any of these issues do occur, they are reported directly into Slack by our build robot so we can find out super fast. Moving on to the character creation aspects. For our skeletons, we have one skeleton of 18 different shapes and sizes, so that's 16 playable, 2 non-playable. The rigs themselves are multi-layered and split into 3 main layer components. Our first layer is our core skeleton. This is a fairly standard skeleton of spines, forearms, legs, and this layer is the only animation-driven or baked component of our skeletons. We then have 2 additional layers that sit on top of the core skeleton, which are for deformation solving and dynamics. These are calculated based on the pose of the core skeleton. So if you don't know what a solver is, you may have heard of it under different terminology, but it's a name we give to a joint that solves a problem that isn't animation driven. So be that for deformation or dynamics. An example of this would be a forearm twist or a roll bone that spins based on the hand rotation to prevent bad deformation on the forearm. The first solver layer is our shared solver layer. This is a standardized set of solvers that every single character shares. This is anything from forearm solvers, neck solvers, lat solvers, bum solvers, and these are all consistent across all characters. The third layer is our character-specific solvers, so these are unique problems to that character. So it might be a shoulder pad or knee pad or a cape or something like that. These 2 final layers are not baked. We do not bake any information onto these bones. We only bake it onto the core skeleton in our FBXs. We then recalculate what these solvers should be doing at runtime every single frame. So we have 2 types of solvers. So there's a skin solver, which is a joint that directly affects the deformation of the character. So if you move it, the mesh is going to move. We have measurement solvers, which are non-skin joints that can influence a skin solver to behave in a particular way. All of these are built upon basic constraints of positional, orientations, aims, and driven keys, which are available in pretty much every DCC. An example of a measurement and skin solver in action looks a little bit like this. So as you can see, the arm raises and the shoulder pad automatically pushes out of the way. The basics of what's happening here is the white joint is aiming directly at the elbow. It is placed on the opposite side of the character to prevent any flipping because it uses an aim constraint. Now you notice as the arm raises up and down, the aim swings up and down with it. So if we look at the channel box on that aim, there's a single axis moving. We can utilize this. We can feed this value through a curve that at specific values tell the joint to do specific things. So in this case, rotate. You may be wondering why we're using an aim and not just reading the arm angle directly, but that's due to the rotation axis on the arm can change depending on how much it's twisted. So if in default it may raise in X, if the arm's rotated 90 degrees it could raise in Y, so it'd be using different axes and wouldn't do what you want. So that's a super simple demonstration of a basic solver that utilizes both a non-skin measurement solver and a skin solver, but these can get super complex. Hierarchically, we create our solvers adjacent to the core skeleton rather than embed them in the skeleton hierarchy directly. This is so we can optimize and log the bone transforms out at certain distances to keep things nice and cheap. And if you note the character ID appearing in the character solver specific names as well, everything associated with the character is nice and tidy. So you may be wondering why we're only baking data onto our core skeleton and then recalculating those solvers at runtime. Essentially, it's due to the fact that we have a solving problem from having real-time retargeting and sharing of animation data between characters. Let's say you have an animation that's authored on Ultimo. You animate him, his rig moves, you bake it all out, and it's going to look perfect on him everywhere. Now, if you put that animation on any other character, it's not going to have the information that other character requires for its deformations to solve properly. The character's bespoke solvers are just going to stay in the bind position constantly. This problem would also occur during ragdoll situations as well, as the solvers just wouldn't know what to do. So since we wanted to have the flexibility to share as much as possible, we decided to set up the character solvers in-engine to mimic their exact behavior in Maya in real time. And since our rigs are built upon basic constraints, we were able to leverage nodes that Unreal offers out of the box that behave akin to constraints. The copy bone, the lerp bone, and the constraint node can all be utilized to behave as parent, pause, orients, or even scale constraints. The lookat node is essentially an aim constraint. Unfortunately, out of the box, Unreal doesn't offer an aim with an up vector object, so we had to make our own one of them as it was a requirement of our rigs. The bone driven controller is essentially a driven key or a direct connection, and we did make our own variant of the bone driven controller with a few extra features. We can then utilize these nodes to essentially rebuild the rig one-to-one inside of Unreal. It is important to note that unlike Maya, there is an operation order in Unreal, so measurement bones need to come before anything they drive. So here's an example of the one I showed you earlier inside of Unreal. This is just a small part of a full character's rig. So as you can see, great success for sharing the same animation data across different characters, and they all solve correctly. So replicating rigs to be one-to-one in engine sounds great, but what does this mean from a pipeline perspective? It means in terms of development, all solving and secondary animation becomes a tech problem, not an animation problem. So the work is on us to fix things rather than animators animating issues out of the way. It also means from a design perspective, all components of a character rig need to work in a logical way, with an if this then that mentality. We cannot have any components that have a magical intelligence or behavior to know what to do. Traditionally, if this was a full animation-based pipeline, the animator could just animate the issues out of the way for a frame or so, but we can't do that with a real-time solving solution, so the rigs need to be solid. A lot of time can be spent making an amazing runtime solving rig. Anything is possible. Ultimately, it always comes down to, is the time investment worth the return? Which brings me on to the title of this presentation. That shoulder pads are never a good idea. So this is a problem stemming from when disciplines collide, art, design, and animation clash. So when art want to create a strong character, they design a character that matches that profile. But then gameplay comes along and the design needs the character performing, let's say, for example's sake, a ledge hang. To do that, animation need to be able to put the character's arms above their head. Sometimes the design of the art won't physically allow for the character to do that. So while shoulder pads were our biggest offender, the issue at hand is when the design isn't fit for purpose, such as limiting a character's range of motions on a game with parkour, or a design that the investment in bringing it to life is more than it's worth. So an example of this is Ultimo today. So he didn't always look like this, he used to look like this. So as you can see there's a 2-layered clavicle pad that's pinned to the chest plate. There's then a huge shoulder pad that is then attached to that clavicle pad. There's then several samurai style bicep pads which are then held together by that shoulder pad. Now imagine him trying to lift up his arms. It just doesn't work. So we spent a lot of development time on that character trying to make it look right, but in most cases it just fell apart under any scrutiny. This was the first time the team had worked together, and this challenge made us evaluate our character creation process and adapt on the fly. We very quickly adjusted to have animation and rigging involved as early as possible in the character concepting phase. This allows us to cheaply identify potential problems in the concepting phase long before there's any significant work developed for the asset across multiple disciplines. Now, this doesn't mean shooting down every piece of art with huge shoulder pads. It's about weighing up the investment as early as possible rather than having issues down the line. Ultimately, in the end, I think we got a better look for the character that worked within the confines of our game design. Pick your battles, especially if you're a small team. Sometimes there's just bigger fish to fry. So runtime solving had some huge benefits to us. It was incredibly helpful for the fluid iteration of our character and their rigs. We're a new IP, finding our art style, what did and didn't work for the characters, removing components and adding new pieces, or even redesigning components altogether, and it all just worked. If we had a system that was more animation orientated, the animators would have found their work being destroyed when updating designs and have to reanimate things constantly. Rigging was able to work in parallel to animation until the very last minute, meaning we can improve the fidelity of our rigs and not require re-export of all of our animations because none of it's baked. Some characters could even be completely redone as long as the core skeleton was intact and not lose a single piece of animation work, and this did happen for Ultimo. It even future-proofed us for outfit skins as they can be made without any animation support whatsoever. Ultimately, the lesson learned was don't bake it, calculate it. So wrapping up on our skeletons, Lord Zero, our highest fidelity mesh, ranged anywhere from 40 to 100k triangles. This was a wide range, but it was kind of dependent on the hair cards as they were a big triangle expense. So characters with less hair on the lower end of that bracket, like Twinkle Riot, whereas Lupita was on the upper end. We have no blend shapes on any of our characters. That was a conscious art resource limitation. Our joint counts vary massively depending on the character requirement, but the lowest total joint count was 170, with the highest being 380. But however, keep in mind not all of these are skinned, so we have a big chunk of these which are taken out just from measurements, and our facial rig is a consistent 60 joints. So Lord 1 is just a mesh density decrease to 30 to 40k. Lord 2 is a mesh decrease again to 10k, but we remove the facial rig at this point, that's minus 60 joints. Lord 3 is a mesh decrease again to 3k, and at this point we remove all solvers as well as cloth. Lord 4, we then do a mesh decrease again to 1k and remove all the fingers and toes. And then finally we have a special Lord just for the server, which is just the root joint, which is not used on the client. As part of our optimizations, we have gates in the Anim graph that we use the LOD index value to strip out relevant components. So LOD 0 evaluates everything. When we reach LOD 1, we get out the facial animation system. LOD 2, we get out the solver graphs. Then LOD 5 is only evaluating states with root motion present. One issue we did have with this that people should kind of keep an eye out for, since we partially run the Anim graph on the server, and the server utilizes a single LOD, which is our last LOD, it does appear to strip out all other LODs, so the index it's returning is actually 0 on the server. So we didn't realize for quite a significant amount of time that the Anim graph was basically evaluating our cinematic character at all times. So yeah, one to watch out for. And if anybody is doing any root motion evaluation on the server, this segment of code can help with some huge performance savings. It basically prevents animation curves evaluating if the animation doesn't have root motion in. As previously mentioned, our animation pipeline was DCC agnostic between Motion Builder, Maya, Max. Animation is just keyframes on transforms no matter what software you're in, so the only hurdle really is swapping between those packages. We created pipelines to allow for that and to allow animators to produce work wherever they felt most comfortable, rather than forcing them into a specific way of thinking, which hopefully can encourage their creativity. We have a custom rig in Maya, we utilised HIK in Motion Builder and Biped in 3ds Max, and then we created various tools across the packages to support this pipeline. On the toolkit side, we wanted simplified tools, kind of based on the 3ds Max approach to concise interfaces, not a ton of submenus and everything's on the right hand side. Automate as many repeatable tasks as possible, things that are done over and over again, turn them into a single button click. It removes human error and decreases downtime to seeing the final result in the engine. And ultimately, just let animators animate, because they'll end up creating some pretty cool things if you do get out of their way. Since the game rig operates exactly the same in engine as it does in Maya, this allows our control rigs to have a one-to-one feedback to the animator so they can see the final result while animating. Exceptions for this do include dynamics and cloth, but this is super useful as it allows the animator to seize the confines of the rig and immediately see if an arm is clipping through a chest plate so they can fix it in animation, rather than waiting until it's in the engine to see the potential problem. So for our custom rig in Maya, we wanted to take a lot of what worked well in 3ds Max and try and improve that into our Maya workflows. One pet peeve of interacting with typical Maya rigs is the control wires for me. Often they're misclicked by a single click, or you've got a drag select to ensure you've selected it. I really like the idea of grabbing tangible volumes like you would in stop motion or with 3ds Max's biped. Inspired by Gwen Frey's approach to control rigs, we brought these volumes into our control rig as well. We then added the option to swap back to original wires or a hybrid so the user can pick and choose how they want it to be displayed, just to not alienate traditional Maya users. We even added functionality to increase the width of the wires or even fade out the volume's opacity so you can be totally see-through, allowing you to just grab the mesh. Big shout out to Gwen Frey who inspired the use of these shapes in our rig, as well as giving us a hand making our in-world picker rather than a UI based one, which is super useful. Taking some additional cues from Max and Motion Builder, we also added limb and full body key functionality into our control rig. So if you set a key on an arm with the limb set, you will apply the keyframe to all components of that limb. Or if you set a full body, it's going to keyframe every single controller. We even color coordinate the keys on the timeline to help identify what type of key it is to the user. These were super handy for pose-to-pose animation and blockouts. We also experimented with FK manipulation of IK, so while you're still in IK with a limb, you can click the elbow or the upper arm and you're still able to move the end effector through FK rotations rather than just translations. On the toolkit side, we wanted animators to get going fast. The first thing they see is the load and unload rig tool. This interface allows for the latest version of the asset to be loaded and fully set up for animation. We don't want the user worrying about the location of the latest rig in Perforce, or finding the correct textures, or even having to pull up the file path editor window. We want them to click the character they want and click add, and the tool's going to do the rest and automatically set the scene up exactly how it needs to be. With a 30 FPS setup and correct units, autosaves and backups enabled so work isn't lost, and unload unwanted plugins and nodes that could cause problems or slow the scene down. A big focus on just getting them started and removing as much headache for them as possible. On the flip side, we also want to get them out of software super easily and into the engine. We have a handful of export tools across the packages, but they're all a one-click functionality to export to Unreal or FBX with all of the correct settings set up for them. You can add new takes super easily if they want to export multiple FBXs from a single scene, if they want batch functionality, if they want to export from different Maya files at once. We also save these export settings into the scene, so they go with the scene no matter who opens it, and so they don't have to be remembered. For our faces, we have a simplified fax-based rig that Mark Cushley from the Post House originally set up. Being a stylized game, we didn't need absolutely every muscle group that's on a face, so we managed to reduce it down to about 60 joints. There's two modes of interaction for the face rig, so we have sliders which control each individual muscle group, and then we have on-face controllers to help push the face even further if a pose isn't being reached by the sliders. We also have a face toolkit window for interaction with the face rig with swappable perspectives if they want sliders or the on-face controls, and keying tools such as key full face similar to the key body and limb tools, and standing mirror and matching poses. One super useful tool was the hotkey loader. While this might sound a little bit useless, it was super helpful. Some of us, in particular Christian, have vastly different alien control schemes that no man can understand. So you can imagine the potential for frustration when somebody needs help at their desk or is helping you and they just can't use the machine to demonstrate or fix the issue. So we added a hotkey loader that stores everybody on the team's hotkeys. This is shared over the network so I can jump on anybody's machine, instantly load my hotkeys, and they can instantly load theirs back after I'm finished. While this was super helpful for a good portion of the project, COVID and work from home made this obsolete. On the technical animation tool side, we had very similar goals with an even bigger focus on automated tasks, as well as focusing on the flexibility to have a non-linear rigging pipelines so we can be adaptable and fluid with art if they need to make any changes. Starting off with our skeleton generation, we have an automated process that creates our core skeleton and shared solvers via a marker-based system. Simply move the markers into the appropriate position, ensure your pull vectors angles are correct for all of your limb bends, and then hit generate. A full skeleton will be generated, including shared solvers ready for you to begin the character-specific work immediately. It removes the fuss and the headache of having to set up a core skeleton and the core solvers every time you create a new character. You can just focus on the bespoke character work. We also have the ability to save and load marker data, or even snap markers to an existing skeleton in case it needs to be regenerated at any point. And because we utilize the same base mesh between all of our characters, we can immediately load a set of skin weights on that mesh that contain all of the data for the core skeleton and core solvers. This gives us a big leg up on the skinning work, and then we can use this to wrap to the actual character meshes. For the face rigs, we also have an automated setup. The tool starts by evaluating our character base mesh and detecting key areas of the face such as the eyebrows, the lip corners and the nose tip. It will then generate a half mask based on that information, which you must validate or correct if it's not as you want. Then, when you're ready, it'll generate the appropriate joints, controllers, face GUI, as well as the preliminary driven keys for all the poses to give you a good head start. You'll have a fully operable face rig pretty fast. While this gets you most of the way, the slider poses then do need additional work to improve the fidelity of the face poses. We also have tools that help you quickly visualize and modify these face poses as well. Our control rig is also automated and one-click functionality to create. The lesson here is that I highly recommend automating as much as possible. These control rigs take around 2 weeks to build from scratch, and with our game of 16 characters at 2 weeks a piece for a rig, and not including any fixes due to mistakes, that's 32 work weeks. That's more than half a year of somebody's full-time job. Now with these automated tools, it's reduced into seconds for every single character. Production's going to love you. One of our newer tools is the ability to automatically rebuild the character rig in Unreal. Typically the workflow when building a rig would be you'd make it in Maya, and then when it's done you'd basically rebuild it one-to-one in Unreal, so you're essentially doing the process twice. We now have tools that evaluate the rig in Maya and then spit out the necessary nodes in Unreal into a single click. Every solver type is automatically pulled over now, everything from aims, orientations, positionals, driven keys, direct connections, they're all automatically rebuilt. This saves a huge amount of time and removes human error completely. The only thing that isn't automatically rebuilt is dynamic bones, such as those that require Anim dynamics or rigid bodies, but there's room for improvement there. For our movement in Destruction AllStars, we utilize a hybrid physics and root motion driven system, where the majority of the time we utilize physics so design have full control of the capsule movement for super fast response. We then have situations where we want animation driven control of translation or rotation of the character, so we swap to a root motion method. So during our locomotion starts, we utilize root motion as well as our plant turns, the ledge hang system and all vehicle interactions. The rest of the time it's physics driven. We want to empower creativity in the animators whilst they're in the editor without them needing to learn the animation graph. To do this, we utilize animation data tables which held all of our animation references used in Destruction AllStars. We utilize the data override system with a master animation table that contained every animation, every physics asset, every blend space, and every variable assignment at the top, which would be then used as our generic animation template. We then had character specific tables which would then override the master assignment for any data that was entered into it. This allowed for a full animation set to always be ready, but also empowered the animators with choice to choose how much content they wanted to replace for that specific character. Exposed within the animation data table were animation sequences, 1 and 2D blend space assignments, exposed physics asset, and a ton of exposed variable properties so they could customize everything from blend times, playback speeds of animations, animation cutoff points to trigger blends, and even alpha values all within the data tables on a per character basis. We also have randomization functionality for animation assignments. Each animation assignment is an array, so the animator can enter multiple animations into a single animation call. Each entry then has its own weight, which is utilized by the anim graph when the animation is called to randomly pick one. We also have a data-driven next animation picker without the need for different states within the animation graph. For this to work, we can place an animation notify with the picker name and value. In this case, we want a different animation to play the next time the animation system lands. So we pick land variant with value 2, and that means the next time the moving land 1D is called, it will be swapped to land variant 2 rather than the first one. And since this is all data driven, it can all be edited at runtime without the need for a reload. Super great for iteration purposes. So with this method, it means animators only have to modify data tables and never touch an animation graph. It's super scalable and the quality and quantity falls on animation. Characters in theory could ship with a master animation set or a totally replaced animation set. And we could also keep adding animation content and updates fairly risk-free. And because of this setup, it means a new character could be running around within minutes. With our mantra to be able to share as much as possible, we wanted to extend this to the facial animation systems and share animation data across characters with different face deltas. As shown previously, we have a simplified facts-based rig. Not all of the characters' faces are the same size or positions, so just baking data and mapping that onto another character isn't going to cut it. We didn't want to compromise on animation control in the engine, so we didn't want to simplify into generic expressions, and we didn't want to use morphs because we just wasn't going to get the range that we wanted without it being super expensive. So akin to rebuilding the solvers, we rebuilt the face rig from Maya into Unreal at runtime. So the way the face rig works is the sliders are just a float value of -1 to 1. So what we did was we basically exported the pose of every min and max slider value. We then stored this in a pose atlas and put that through into Unreal. Then when exporting, instead of baking the face bones directly, we would bake the slider values into the animation as float data. Then in Unreal, we can read that float data and pass that through the pose atlas, which would then rebuild the facial pose exactly the same as in Maya. And since we're utilizing the slider values to rebuild, we are then able to place any character's pose atlas through the input, and it will give that character's unique delta, so we can share facial animations between every character. One of our more useful nodes is called speed warping. If anybody's watched Paragon's animation talk, they may be familiar with this tech, but it's essentially a node that can widen or shorten the stride length of an animation procedurally. So as you can see in the video, as the multiplier is increased or decreased, the length of the stride is adjusted to account for it. The pelvis is even pulled up or down to prevent hyperextension. This is super powerful and protects animation from potential design changes. So let's say you get an example where design want a character running at 5 miles an hour. So the animation team go away and create a full locomotion system that runs at 5 miles an hour. Then design decide to come in and change the run speed to 7 miles per hour. All of a sudden those animations are invalidated and you're going to have a bunch of foot sliding. This node protects against that to some degree. So you have the animation input speed times the distance it's actually traveling, and you can scale a stride length up or down. Within reason, however, there is a threshold where it just begins to make the data look bad. We utilize this primarily in our character's ability mode, where the characters move faster. This does a lot of the heavy lifting in those situations to increase the stride length without the need for a whole alternative locomotion system. But again, with the data tables, this is entirely scalable on the animation team. We do allow for animation swaps during the character ability mode, but that is resource dependent. So we can ship without the alternative locomotion system and just let speed warping do the work. So animation driven ragdoll, or ADR. I'm sure everybody's familiar with ragdoll. ADR, or physics animation as it's sometimes referred to, is a tech that's essentially halfway between animation and ragdoll. So imagine you've got a scale where 0 to 100, where 0 is ragdoll and 100 is animation. ADR is a system that lies somewhere in between. You're essentially applying forces to a ragdoll to pull it back into an animation position. Some of you may be familiar with the fantastic GDC talk that Naughty Dog's Michael Mack did on physics animation in Uncharted 4. It's essentially the same thing. Here's our technology proof of concept video we did in the first year of development, demonstrating ADR on our passengers. We knew that this was something we wanted to pursue, as it gave incredibly organic animations that would be very intensive to create by hand. And this is what we shipped with. The driver and the 2 states of passenger all have ADR applied to it. And while it creates some really organic interactive animations, it's a super time consuming task as we had to have unique data on a per skeleton basis due to the differing masses and volumes. And throughout our implementations, we did learn that sometimes less was more, and giving it a basic underlying animation system and giving it a nudge in the right direction made the fidelity of the ADR look infinitely times better. In the engine, we also have gameplay metric visualization tools that help you preview an action's distance over time metrics. These are super helpful to visualize design's gameplay metrics in a visual form rather than looking at numbers in data tables. Character actions from start acceleration times and distances to jump distances and heights, all sorts of measurements for actions, which is really helpful for animation. As part of our gameplay systems, we feed in information about the world to the character as part of our attention system. This is an events-based system that acts as a form of diegetic UI, but most importantly connects the characters to the world around them. Events include if you've called your hero vehicle, the character will point at it in case you've lost it. If there's an enemy off screen that's about to run you over, the character will begin to panic and look at you to let you know. The characters also look at points of interest in the world, such as objectives, empty vehicles, and other characters. The attention system is entirely data-driven, with each event having a series of parameters that define if and how it influences the character. There's a priority order, so more important events can take precedence over lesser ones. Time duration attributes for attention duration and significance duration, the distance the event has to be within to become significant, as well as measuring if the player is facing that event or not to justify the potential focus on it. In game, we have some debugging visualizations that help configure this data, with the blue lines being potential attentions, green being the significant attention, and the pink and cream lines are the body and spine relative vectors which are utilized for the aim systems. So Destruction AllStars isn't entirely character focused. We've got the whole component of vehicles in our game, which adds an interesting degree of complexity and problems for us when our 16 heroes need to interact with dozens of vehicles that are fully destructible. Entering those vehicles could be a problem for us. So animation investment on doors and entry to vehicles is colossal. There's so many variables to take into account with an entry system like this. Is the door open or closed on the car? Is it partially open or fully? Has the door been damaged or even destroyed, meaning the handle will be moved or absent? Are you entering from the left side or the right side of the car? You might have to account for moving over to the correct driver side of the car. What's the distance to the car? You might have to pathfind to the entrance. Is the vehicle moving or is it on a slope? What's the environment surrounding it? Is the door blocked? What's the size of the car? Where's the door handle? Are you driving a mini or a big truck? So the door handle is going to be lower or higher. Is the car upside down? There's so many variables to take into account. As a small animation team, we knew the resource investment to get 16 characters into a dozen destructible different size vehicles was going to be massive. But early on, we did come to the solution of sunroofs. So when prototyping, we were designing an ejection system where you can tap X and you'll do a big jump out the vehicle from an ejector seat. As part of this, we needed a sunroof, which became pivotal in finding our efficient solution to our entry problem. We decided that the sunroof was going to be the entry and exit point from the vehicle, so vehicles wouldn't have operating doors, they'd be covered like derby cars where the doors are welded shut. In addition, we utilised a standardised central cockpit for the cars, so all of the drivers were in the middle of the car rather than favouring the left or right side. All of the cars also shared the same size cockpit, meaning we didn't have to have bespoke cockpit animations per car. So we ended with a standardized sunroof, with standardized handlebars for entry, a standardized cockpit and steering wheel sizes. The only thing that wasn't consistent was the distance between the sunroof and the chair, which we accounted for as part of our entry system. This centralized cockpit with sunroof also aided in our character heights too. It gave us a lot of freedom with characters with hats or taller characters to sit into the smaller vehicles without any roof clipping or needing to scale the character. They could just poke their head out of the sunroof. This also had some benefits to our destruction system too. It allowed for a much greater crumple zone around the car to be destroyed because the center of volume is the only bit that needs to be preserved, giving tons of freedom for the cars to crumple in around them, which would have been an issue if the driver was favouring one of the sides. So in the end, we have 5 directions of entry. That's a front, back, left, right and a top, as well as 2 distances for that, a near and a far. That meant 9 animations got you a full vehicle entry system. Then the animators could leverage the animation data tables to do character-specific entries where necessary to add character moments where they saw fit. This standardization allowed us to add new cars freely of any size with 0 animation support. On Destruction AllStars, we had the opportunity to work with some amazing partners. One of our partners was Audio Motion, whom we did our motion capture with. They're based in Oxford, so they're only a few hours drive from Lucid's office. The team over there are awesome and their data is super clean, so if you ever get a chance to work with them, I highly recommend. We had 3 shoots across the project. There was 2 locomotion shoots and 1 stunt shoot. As you can see on the right hand side there, we had a 9 meter tall volume, tons of crazy wire work and the stunts, which was super cool. Across the shoots, we had a ton of amazing talent to work with, from professional parkour and free runners to actors to even 2 Ninja Warrior winners. They were all an absolute pleasure to work with. As you can see, we had a ton of fun. We even set up live streaming of our motion capture data into the engine with their tech lead Connor Ling. Once the live streaming was set up and it was on the monitors on the capture stage, we very quickly realized the massive benefits that this live stream was giving to the talent. They no longer felt silly or awkward in their skin tight suits trying to imagine what they are. They can see it. It was invaluable. This led to some really interesting situations where the talent were goofing around, and we ended up secretly recording the data so we get some pure gold natural data. Steamroller Studios are another one of our partners. They're located in Florida, so interacting with them is unique and comes with its own set of issues due to the 5-hour time difference. They're a team expansion of our animation team. They're super talented, and it's been an absolute pleasure working with them, and I cannot recommend them enough. Working with them for the past few years really helped us prepare for the work from home lifestyle, in all honesty. Having required webcams to talk with them meant we all had webcams before the great toilet paper and webcam shortages of March 2020. We had a handful of animators from Steamroller for the better half of the project, supporting gameplay and character select work. Then towards the end of the project, when the cinematics got greenlit, we expanded the team further to help support those animation demands required. So while Steamroller primarily led the cinematics, the responsibility for integration was on myself. It was important that I was not a blocker to them seeing their work in the engine and identifying potential problems ASAP. There are hundreds of animation files associated with the cinematics. The intro cinematic alone has all 16 characters with an animation off the camera. So that's 17 animations per shot, and there's over a dozen shots in that first cinematic. That's a lot of data. Manually integrating this data didn't really seem like a viable choice. It'd have turned into a full-time job with the amount of cinematics we had. Alongside the cinematic integration, I also had all of my regular responsibilities for the gameplay side of things, so an automated pipeline was a must. Unreal has Python integration now, which I leveraged to create an automated cinematic sequence setup. I'd point the script at a particular folder and it would do the rest. It would import all of the animations to the relevant folder, set up their retarget settings all automatically. It would then break down each animation asset into its respective take. It would set up a relevant sequencer file, import all the relevant blueprints, track the appropriate tracks and assign the animations to those appropriate tracks. It would then set up a camera and import that in with all the camera authored data on it. It would even set up folders in the sequencer file and organize it nice and neatly. And finally, create a master sequencer file that all these cinematic takes lived in. This saved days, if not weeks, of manual labor and turns it into a 2-minute trivial task so you can focus efforts elsewhere. The cutscenes themselves were designed as real-time cinematics, so working with them and making changes on the fly is super easy. You could even swap out the skins or even swap out a character for another. Unfortunately, due to time constraints and risk mitigation, the end result you see in the build is pre-recorded version of those real-time cinematics, as we deemed it was too risky to submit thousands of animation files late on in development with tons of points for potential error, while a single video replacement is much safer. And some final thoughts from me. So this was my first time going through a full development cycle, and this is some kind of advice I wish I knew going into it. Sometimes you can be too close to a problem. Several times I've smashed my head against the wall trying to find a solution with no avail. You just need to log out and come back to it the next day. Fresh eyes will give you a whole new perspective on the problem. I can't tell you the amount of times solutions have come to me in the weirdest ways, at night, in my dreams, or even in the shower. Don't get bogged down by breakages or bugs. I've always looked at that as a big failure on my behalf and how I didn't find it before I submitted. It happens now and then, you just have to be proactive. Sometimes these are a good thing. It helps you evaluate processes and your work is being used in a way you never thought of, which can then make the fixed work even better. Don't be afraid to ask questions. Not everybody knows everything, and asking a question doesn't make you look stupid. You're more than likely at a game studio going to be surrounded by some incredibly talented people. I myself was lucky to be surrounded by people doing it longer than I've been alive, and they don't even have to be from your discipline. Get some perspectives from people not on your doorstep. Don't get overwhelmed. Try not to get lost in the mammoth scale of tasks you need to do. Just focus on one thing, ignore the rest and move on. Don't try to tackle all problems at once. It's not going to help. Don't be a dick. You will be remembered. This industry is disgustingly small. Everybody knows everybody. I genuinely thought that was a thing industry people just said, but it's so true. And finally, you can't see the forest among the trees. Sometimes you can't see what's right in front of you when you're working on it 9 till 5 every day for over 3 years. Take a moment to appreciate the work you've done and be proud of yourself. So, some key takeaways. Animators just want to animate. Remove the fuss, just let them do their job. They're going to create some cool stuff if you do. Don't bake it, calculate it. Really great method that worked for us in our rigs and allowed our pipeline to be super flexible. Pick your battles. You and your team are only a finite resource and there's only a finite amount of work that can be done. Pick your battles and don't try to do things that aren't necessary. Automate as much repeatable tasks as possible. You're going to save so much time to spend on more pressing tasks. Iteration is key. Don't work up to a deadline and submit that work as final. Get it in as fast as possible and get eyes on it. Iterate over that work and it's going to make it leaps and bounds better. And most importantly, shoulder pads can be a good idea if done correctly. Thank you for listening. This is my first game. I've learned so much. Super proud of how such an awesome team I've been working with for the past few years. I really do hope you love our characters. There's bits of us all in them. Like Lupita's even got my teeth. But if you've got any questions, feel free to follow me on Twitter @MattLakeTA. Thank you.